Hello everyone, welcome to Professor 3Mac, and in today's video I'm going to do a small surgery on a model file which was sent by one of the subscribers. The aim of the work is to perform ballistic impact simulation where a ballistic bullet, in this case it's a cylindrical bullet as seen on the screen here, is impacting at a speed of 100 meters per second with a composite wall or plate. And the subscriber has used Hashin damage model and is coming, and when you run the job then you find out that it gives an error message which says excessive rotation, and we're going to solve this issue out, and I will give you some tips on how or what to check to remove this error. And later on, by being worried guy with lots of errors, we will make it run as you see here. Again, I will not fully run the job, but I will just show you how you can make it work and at least go to a stage where you can see damage and all the actual mechanics which you really are after for these kind of simulations. So hopefully you will be happy after looking into this, and you will be able to learn how to remove these kind of excess incremental rotation errors and also excess element distortion errors in continuum shell elements using Hashin damage model. So see you on the other side. Okay, now let's look into the ABAQUS environment, how the model really looks like, and then maybe do some housekeeping of the model and also check for the correctness of different parameters which needs to be defined, while try to see how we can make this error go away. So let's look into it. Okay, so if we look at the parts, we had bullet, and then we have two plies, two of the models, 90 degrees and 0 degrees. In this case, I think 0 degree is used, so I'm gonna keep it this way. And then also 90 degrees used as well, sorry. So if I show you the properties, then the material properties are defined as elastic properties, which are Young's modulus and Poisson's ratios in 3 different directions, and it's in terms of engineering constants. Density is defined as this. Again, I think everything is in millimeters, so all the units are consistent with that, so I don't see any anomaly here. These are all megapascals. Similarly, for Hashin damage, you need to define the longitudinal tensile strength, compressive strength, then transverse tensile and compressive strength, and then longitudinal and transverse shear strength. And again, these are all in megapascals, and I think they are very typical values. So for this kind of composite, they range in the same values, so it looks okay here as well. So I don't see anything which can trigger any warning lights. Now if you look at the damage evolution, as you know, you can basically apply damage evolution from here. So it's already there. So again, in this case, energy linear is a default option, and they are defining the fracture energies. Again, they must have been taken from the literature, and these units should be Newton per millimeters. So longitudinal tensile fracture energy, then longitudinal compressive fracture energy, and then transverse tensile and compressive fracture energies, and these are the values which are in Newton per millimeter. So again, they are very typical values, and they are similar range for different types of composites, so I don't think there will be any problem. Generally, this part is problematic when it goes towards the damage evolution, because your elements will lose their strength, so their stiffnesses will be negative, and also they will deform a lot, so this can cause a lot of rotation and also distortion. So always define these values very carefully. If you come across a lot of problems with convergence, and then there is always an option for damage stabilization. Again, you can specify some coefficients here, 1 exponent minus 4, 5, 6, whatever. Should be very small as compared to the time increments and all the other things. So I'm not going to do anything on this right now. Then obviously what they have, so I'm not going to save anything here. Then they have not assigned anything, but they have used this to define most probably the plies. So here you see composite layup for each of those, and you can see ply 1 with material one, which I just showed you, and the thickness of the ply is 0.3, and there are 3 integration points, and it's in this case the rotation is 90 degree. That's why they call it 90. Then similarly for 0 degrees, there must be a similar sort of thing, but the angle should be 0 degrees, as you see here. So this looks correct. I don't see any problem here. If there are lots of problem with convergence, in this case it's explicit, but in any case, so you can play around, as I said, with these two things and see if you can improve the convergence of not only for the solution, which is more relevant for static analysis, but for explicit, the distortions and also rotations. Okay, next is assembly. Assembly is just assembling two parts. So this is a projectile which is having a velocity of 100 millimeters per second, and this is all fixed. What you see here is there are around 1, 2, 3, 4, 5, 6, 7, 8 plies, and they must be 0, 90, 0, 90, 0, 90, as I have checked before. So hopefully this is the case here. So you can check that here in the assembly. And if you look at the parts, you see 0, 90, 0, 90, 0, 90, and then finally the bullet. So they are assembled this way. So this means somewhere in the model they must have defined the tight contact between them as well. And if there is any fracture law, then you can define fracture laws as well. But we will see what is there. Now, step definition is an explicit analysis. The velocity is the total time period is this, which is 3 exponent minus 4. Everything else is kept to default, so nothing is changing here. Then we go to interactions, and you see there is one interaction defined here, so this must be the contact between this projectile and the surface, hopefully. And I think this is the case here. It's a general contact, and yeah, so it looks like that here. So that's fine. And then interaction contact property wise, tangential properties are the friction coefficient of 0.3 is used, and it's a penalty. Generally penalty is recommended, but again you can see what's going on. Rest is all default. You see there are no values there. Oops. And also normal contact, if you look at that, it's hard. If you don't define it, even then ABAQUS will assume it to be hard, so that's default as well. So this is between them or any other contact which is happening. Other than that, if you see any constraints, so yeah, so this is the tie constraint between different layers most probably. So 0, 1 and 91. So let's see, if you press edit, then it will highlight this. So this is the contact between tie contact between these two layers. And if you look at the 0, 91 and this, then it should be the next one, and then it will move in this direction. So let's say if I do this one, then this should be somewhere here, and here you go. So this is how it looks like, and I don't think you need this rigid body constraint because you already made this part as rigid. So you can remove it if you want, or if you want to keep it, just keep it. But I don't think this is redundant, because if you go back to your part module, and if I show you the parts, then you see this bullet is a rigid part. So oops, it's locked, so you can't see it. So if I unlock it, I hope I don't mess with anything right now. Yep. So now if you look at this, so it's basically kind of a rigid part. And anyway, even if it's not, then you can make it rigid using that interaction. So anyways, you will come back to that and check it again. From the loading perspective, there is no load here. There is, you can see there is a fixed boundary condition on the surface of this composite, so it's in caster. And then there must be the projectile has a reference point here because it's a rigid part. So all the directions, degrees of freedoms are fixed, except for u3, which is the z direction where the projectile will be moving in. So for that, for the projectile speed, the initial speed is defined to be 100 millimeters per second, and everything is in millimeters. So they have used, all the subscriber has used 100,000 millimeters per second. And as you can see, it will be computed throughout the analysis. After the impact, the velocity will change since it's a bullet or ballistic impact. Anything else? Nothing else is there, so this looks fine. Mesh wise, if you look at the mesh, so this one is basically, if you click on this, and this will show you, so these are discrete rigid elements, so this means the material was meshed with the rigid parts anyways. Then if you look at the 90 in this degree splice, then they should be continuum shell, as you can see here, and everything is default. Element deletion is selected to be yes, because we need to delete elements. So these are SC8R elements, which are 8 noded quadrilateral in plane general purpose continuum shell elements. So although you made this geometry as 3D, but you can use these continuum shell elements to define this geometry. And remember, there were some number of layers in it. Okay, anyways, this is how it looks like. So, and then you go to the job, and as I told you, when you run it, you come across this error just there. So let's see if we can somehow improve anything with this. So in my opinion, and the first thing you can do, or first thing I would do, I would just try to first get rid of, normally these kind of excessive distortions come, incremental rotations come due to the interactions, or maybe material properties, or maybe a very large time increment. So let's do one by one what we can do. So in this case, what I'm going to do, I'm going to make few changes. So let's say if you look at the damage law, which is used here, Hashin's damage law, then this is the law, and you see the fiber tension where you want to have an initiation criteria, you have a value alpha, and this shows, this alpha basically characterizes the contribution of the shear stress to the fiber tension initiation criteria. So generally it can vary from 0 to 1. Again, you can look at the Hashin's paper from 1970s and 80s, and many other papers are there. In this case, I'm going to use 1 just to couple this part, so that there's a mode mixity effect when the fibers are failing, because it's a complex loading here. So this is one thing I'm changing. Then the next thing I'm going to change is the total time of the simulation, because as you can see, the total time is very large, and I think this will be too long to compute. So let's see what is the distance between these two parts first. So 2 security distance. We are after the distance in that direction. So if you look at the distance components, and then it's 6 exponent minus 3. So 600 exponent minus 3, which means it's 0.6 millimeters. Okay, so this is 0.6 millimeters, and let's say if I let it travel in the same direction for 3, 6, 9, 12, 15, 18, 21, 24. So 0.24. So 0.6 plus this, so this is 0. Because you see this, the thickness of each is around 0.3, I think, as for the geometry. So 0.3 times 8 is 2.4 plus 0.6, so it's 3.0. So 3.0, and I give another 3, so it will be 6.0. And if the speed is around 100,000, then the total time to reach to this kind of thing will be this over the distance. So that will be 100,000, and that will be 6 exponent minus 5. So let's give it something around 7 exponent minus 5 or something, or maybe 7 exponent minus 5. Again, I'm just computing based on the speeds, then minus 5 speeds. So you can again compute based on the distances and the speed which is with which the projectile is going, because if you give 0, this big value, the projectile will going through very far away, and we don't need that long simulation. to save computational time, it's really important that you actually use the time which is needed rather than just giving any large value. Also for incrementation, sometimes what happens when these excessive rotations occur, and if you're happy with material properties and also the interaction, then the best is to scale the time factors. So in this case, the time factor, scaling factor is 1, so I'm going to use a value which will reduce the time increment further. So let's use a factor of 0.01. Rest I'm not changing anything, and you can see everything is global and everything is all default. Other than that, friction I told you is already there, so let's see if it improves anything or not. So other than that, yeah, so this is all done. So I go back to the jobs, and if you remember the monitor, and it only went up to 7.26 exponent minus 6. So let's see if it improves. Let the simulation go further or not. So keep this thing in mind. Let's press submit and see if anything is improved or not. Because I know when you get rid of this rotation effect after reducing the time increment, and if your parameters are not good enough or your mesh is not good enough, then you might come across the distortion, element distortion errors at the end when elements start to delete and there will only be few elements left. So we will look into it. Let's see. So I'll stop the recording and I'll get back once the simulation is in a stage where we can see some results. So see you in a bit. Hey, welcome back everyone. Now, as you can see, unfortunately this thing has aborted, and this means it couldn't finish, and now we see the error message, and you can see the error message has changed from excessive rotations to excessive distortion. So now during the damage evolution part or after the damage initiation, your elements are distorting too much, that this kind of error is coming. So this could have many reasons, but before going into that, let's look at the results and do the postmortem study to see what is going wrong. So here is the model file in the ODB, and you can see it has impacted and it has done some stuff. Let me remove the projectile thing and see if, how it looks like. So you see it looks like this, and if I, and you can see there is clear indentation marks, so this means everything is working fine. But if you look at damage parameter, oh, and you can see now these are the issues here because the subscriber has not asked for anything related to damage or status of the elements. So ABAQUS might be struggling to delete the elements once the damage has reached to a certain value. So again, we need to ask for those outputs as well. So I'm gonna go back now to the step module and see how the outputs are being asked. So you see in this case for the whole model, the outputs are these, and there is no inquiry about the damage. So let me ask for all the damage criteria for fibers in this case, and I hope this will work. But let's select this as well. One of them will not work, but let's do that. And also you need to ask for the status, because if you remember, status is 1, this means your element is in the simulation. If the status is set to 0, then it's the other way around. Oh, so we will see. So I have to ask for that as well. Otherwise, you will always see some distorted elements rather than the deletion of the elements. Also for the mesh, I don't know if I checked it or not. So if we go here and see, so element deletion is yes, so this is fine. Oh, this is the same for this one. Yep, so this looks okay. So now what I will do, I will just run it, but you can see it's taking a long time. So maybe to reduce the time, of simulation, and rather than I'm wasting whole day on this, I will remove some of these layers. Maybe I will keep only one of these layers, last layer, and then run the simulation and see how it looks like. So that's what I'm going to do now. I'm going to go to the assembly module. So now you see it's came back. I don't know which one has been removed. So now I will remove each of these layers one by one. I will remove each of these layers one by one now. I think I have removed the wrong ones. In any case, we can live with that. So delete this layer, delete this layer maybe. So I'm just removing some of these so your computational time is reduced, because I'm not interested in delamination at the moment. So subscribe and hopefully can live with this. And so now I have only one layer, and it's a certain distance. Again, I'm keeping the distance the same. Again, you can reduce the total time from 7.6 to something else, because you don't need any more time now, that much time. But let's do this. So now I have only one layer. I need to go and remove the interactions, especially these tie constraints. I'm gonna delete all these because there is nothing to tie here now. Also, I don't know about the loading conditions now, because initially this was applied to the bottom one. So now we have to select the surface of this to apply this bonding. So I'm going to select this, select from viewport, and now I'm going to select these, shift, and then this, and then I will rotate and go on the other side. There you go. And now it's done. So now you see boundary conditions are back. If you look at the view here, but just to double check if everything is fine other than that. So this is fine. Initial condition should be fine because we didn't do anything in that. Yep, so it's still at the reference point. And yeah, so everything else is okay. Maybe time step I need to decrease further, maybe make it like because it's much nearer now, so maybe make it 4 exponent minus 5 or something. And again, you can compute based on the distances that I showed you just now, but just doing it quickly to save my own time here. Apologies for that. So it's submitted. Let's monitor it. It should be quicker this time because only one layer. So there is an error. Okay, so you see the Hashin damage criteria. You can't really ask for an output because there are some of these. For example, this ballistic indenter or bullet, whatever you call it, is a rigid, and you can't really output for that. So maybe either change it to only the part, or maybe we don't need the Hashin, we just need damage. So I'm just gonna live with the damage for the time being. And now I go back again and rerun the simulation. Monitor, and hopefully it should start. Now it's doing the pre-processing of the data, which is completed. So everything is defined correctly, almost correctly. And now it's started. So we will see something happening here. So see, now it's much quicker. Last time it ended at around 1 exponent minus 5 or something. So let's see where it goes this time. And okay, so output wise we have 3 frames already. So we should be able to see some damage, but let's wait for a few more frames. So now I think the impact must have happened. Let's check results. You can check during the analysis as well. So you see these are during the analysis, and you see stresses are high. It's one layer, so you should be seeing something at the back as well, and you see it is indenter is trying to come out. As you see, and elements have started to delete as well. So let me make it only free edges, and you see these elements are deleting, and you see it's going through really well. So your elements are deleting, but still you see a large, these are very large elements, and again there will be some kind of distortion here, which might be causing some problems. So let's see, there is an error now, and if you monitor again, so this error is again due to the distortion. So now we have to see how we can sort the distortion error out. Again, go back, and here now you see status, you can see damage criteria, you see they are all, these elements should be deleted by now, but they are not deleted and they're very elongated, so you are getting this distortion error because of that. So let's see what we can do here. Again, check the properties. If your elements are too ductile, then what you can do, you can reduce these values depending on, again, very close to experiment. Again, where experiment has a variation in these values as well, so you can play with those. You can use this stabilization option, which can also improve the convergence, or you can go to the tab here and maybe also you don't need this, and I think up to 2 should be enough. And also here you can reduce it further, so maybe make it 0.05 or something, because then it will improve some of this. Sometimes these factors can also help you to eliminate those, but let's try first this thing. So remember last time we went up to 1.7 to exponent minus 5, and results are pretty promising. As you see, everything is getting deleted, but let's give it a try one more time with the new time increment. So start it again. Okay, let's look at the results now. So this is how it looks like, and you can see up at 1.77 you have almost all the elements deleted, and your simulation seems to be working fine. Still some elements are struggling, so these are very elongated elements, and again you can play around with this time increment further, and you can basically get rid of those as well. So if you just decrease this time maybe, or try something else, that would also be helpful. Finally, I will also show you, or to demonstrate that material properties are also very important, and some people might argue that I changed the material properties. So what I have done now, I have brought it back to 0. This means there will be no shear component of the stress which will be contributing towards the fiber tension failure. So I made it 0 in this case, and I rerun the simulation with the default parameters, this mean for material at least. Rest I already changed, and are very much the same as what we got for the material parameters with alpha equals to 1. But in this case that damage was delayed, so it ran for almost a double time than that. So you can see, you see the failure and everything in the trend. So I don't think you need to go more than that in this case, but if still you want to go more than that, then again you can play around with that, and also you can play around with these time scaling effects, and as I told you, with the material properties. So I will stop at this point since I have given you some tips, and so damage stabilization, you can also include that. So some of those tips are there. So anyways, I hope this video will help you to rectify these kind of issues. And as you can see, if you solve one problem, then there is always another problem coming in. So we solved the error of excessive rotation, incremental rotation error. but then we have the distortion error, and again this could be because of material properties or the mesh even. So you might also think about finding the mesh or changing the mesh as well, which can also improve the results by doing this. Again, unfortunately, ABAQUS adaptive meshing doesn't work with these continuum shell elements. Also, these continuum shell elements don't have the distortion control option, which generally is available with the solid elements. So we can't use those options here. So I'll see you in the next video, and if you have any other problems, then always comment below and I will try to help you out as much as I can. So thank you very much and bye for now. So I hope this kind of helps you out. We had at the start, we had the incremental rotation, excessive incremental rotation of error, which we removed, but then we found out that due to the material properties or due to the time increment size, we have excessive distortion. So we also looked at the fact that how we can remove that, and we are now able to actually simulate this until the point where you have everything failed and everything really looks promising. So you see here you can get into different failure criteria, for example fiber tension failure, and you can see these elements are failed and these are basically causing this. Again, these matrices should have been failed and separated, but they haven't because of the material properties. So again, you can play around with the material properties to improve this thing as well, because I don't see any other issue here. Also, as I told you, check the step time scaling factor, so you can scale the time increments, and that can also help you rectify this kind of high inertia problem. So I hope this helps you out in rectifying the errors related to the excessive distortion and also excessive incremental rotations, and make your simulation go ahead. So thank you for watching, and if you have any more comments or if you have some more ideas to remove these kind of errors, then please comment below and we will have a discussion on that. And if you have any other issues which you face in your job, then again you can comment below and I will try to help you out as much as I can. So thank you very much, and I'll see you with some more interesting videos in the future. Bye for now.